So when we're judging the performance of different functions or algorithms that we use a thing called Big O notation. You're either learning about this or are going to learn about this in the class, but essentially what Big O notation is that it takes an estimated projection generally of the worst case of a function. So if you gave it the worst set of data that would make it take the longest, how much time would this function take to execute what it's supposed to do? Big O will allow us to group different routines based on how efficient they should be for different tasks like searching or sorting. Remember that Big O is only an estimate. It doesn't take into account what type of data it has. So some functions can do really well in certain situations, but if the data is organized in a certain way that exploits the weakness of that function, it would do very poorly in that situation. So it's good to test these functions within the context of an actual working environment. And that's what we'll do in this lab. So for part one, we are going to compare the Big O runtime of 3 different searches, 2 of which you should be familiar with from 110. The binary search, you might remember, basically splits a list in half and checks whether the key it's looking for should be on the left or right of that middle spot, and keeps splitting in half until it finds that key. The linear search just goes from the start and cycles all the way through the list until it finds what it's looking for. And then we'll have an unknown search thrown into this as well. In order to test this runtime, we would need a timer. So we would need a function that would get the current system time. We would then execute the routine. We'd get the system time of after the routine is finished. And we'd take the second time, subtract the first time. That would be how long it took that function to execute. The problem is, with just running it once, it's going to run so fast that it's going to be hard to get reliable times. So we're going to run this function many times on large sets of data. In order to do this, we are going to need to set up our timer library. So a library is a collection of object files. Depending on the system, they're either .obj or .o. In our case, they're going to be .o. The object file is basically a CPP file compiled into an object file. It contains individual functions, collections of functions, or class implementations. Every object file, when it's put into a library, is stored individually. So when it is accessed in that library, the compiler looks for that certain object, grabs the information out of it, and takes it into the program. Header files are also needed when you're using a library. Every library has at least one header associated with it. The header files relate to the functions that are going to be used within that library. These are when you're using the include preprocessor command. So they get the data types, they have the function definitions, things like that. Why you might be interested in creating your own library is that if you have a set of bug-free code that you never want to change, it's good to just make it into a library for a few reasons. One, if it's a library, it's harder to change it, so you might not accidentally edit it. And 2, if it's a static library, when you compile with that library, it'll actually compile faster. So it's useful for both of those reasons. So we are going to make a timer library, and there's 3 steps. So creating your library is done by writing 3 commands into the console. You're going to first compile an object file with g++ minus c, timer.cpp minus o, timer.o. Then you're going to write ar for archive with the flags rcs, timerlib.a, timer.o. This will create your static library file named timer.lib. And lastly, when you compile these files, you're going to want to use this library and not the timer.cpp file. So you'll compile any files with this using your timerlib.a. So to try this out, we can go g++ -c timer.cpp -o timer.o. AR for archive, RCS, timerlib.a, timer.o. Then lastly, g++ complexity.cpp, timerlib.a. That generates an executable for us named a.out. So we'll run that. And that just demonstrates how the timer works for you.